Okay, well, welcome back, everyone. This is the first in a series of videos where we're going to discuss file input and output, file I/O in C. And starting things off here, I want to just jump in and talk a little bit about how this compares to some of the previous videos that we have discussed topics previously. So in previous videos, we've been exclusively dealing in the memory world, right? We've been dealing with memory and not your computer's file system. So then you might ask the question, well, what's the difference? Okay. Well, memory is considered your fast and volatile storage. Okay. This is where you're storing information in a way in which it's the access time is quite fast. Okay. And volatile means that if you lose power, right, the data is gone. Now, this is something that you're already familiar with in one way or another. You think about when you're running something on your computer, right? If it's not saved to your file system, right? If it's not saved to your file system and you lose power, right? You know from probably having some bad experiences earlier in your life that that data is gone, okay? That's because as soon as that power is no longer supplied, that's it, okay? Right, so but there's a trade-off, right? You've got this loss of information when you've lost power, but you also have this fast storage, okay? So previously we looked at memory in the context of different memory regions, how they're going to be used, static memory, stack memory, heap memory, right? Now we want to expand on this a little bit more and talk about not just memory, but also your computer's file system, okay? These are actually really large topics. When you're talking about, memory and file systems and everything, this is stuff that there's more advanced topics that you see in other classes. I've taught an operating systems class before. You go into some pretty, you go into a lot of details about the operating system's role in managing your memory and the file system and everything. But that's stuff for another day, right? What we care about in the context of this class is how we are going to use the file system to write files and read from files, right? We want to be able to read information to and from files, and that's what we care about, and that's what we're going to be focused on, okay? So we've got this memory here. This is our fast and volatile storage, okay? And in contrast, your hard drive, right, is much slower, right? Many orders of magnitude slower, okay? And it's actually pretty shocking if you look at the numbers about how much slower it is versus some other types of storage, okay? And it's a moving target, right? This picture here is showing a kind of an older mechanical hard drive. Okay, you may or may not have that in your machine right now. These are starting to become less popular as people shift to these solid state drives, but the underlying mechanics are the same, in which it's slower than your memory storage, okay, and it's also non-volatile. Okay, so then obviously non-volatile, what I'm referring to is that you've lost power, that data is still there. Okay, so that actually makes sense, right? If you save a document on your computer, right, you can turn your machine off, right, come back to it later, and you're going to still have that data. Okay, that's because it's being preserved on your file system, and your file system is being stored on your hard drive. Okay, now it used to be that hard drives were really they had these mechanical components to it, where they literally had a physical disk that was spinning, and a mechanical head that would go and actually move the head to retrieve data off the spinning disk. They're still around, right? But they're phasing out in terms of the solid state drives that don't have all those mechanical parts. They're substantially faster, okay? But they're also more expensive, so there's a trade-off there. Okay, but conceptually it's the same idea. That's where the file system is. Okay, the file system's being stored on the hard drive, being stored in this slower, non-volatile storage. Okay. All right, so your file system, okay. Your file system is what you're seeing when you're kind of moving around, you're kind of file explorer, right? You're moving around, navigating between folders and files, stuff that everybody's familiar with doing, right? You're kind of doing it intuitively. And so you got a mix of folders and files. Not only do you have the information that's being stored in the files, but you also have additional properties being stored, like the last modified date, the size, the name of the file, all these other kind of metadata properties that are corresponding about a particular file or folder, right? Metadata being data about data, right? It's the data about the data that you're storing, okay? Like when was it last changed? When was that file last changed, okay? So when we're talking about the file system, that's what we're referring to. That's the visualization, is the sequences of folders and files that you are going to be, that you're navigating around on your computer's hard drive, right, on your computer's file system, okay? Now, so this is something that most people deal with intuitively, having been familiar with it over so many years, is the fact that your file system is being stored in a hierarchy, right? You've got these series of directories, these series of folders. Folders, contain other folders, as well as files, right? So you've got this hierarchy, right? At the top of the hierarchy, also often referred to as the root of the hierarchy, right? That's typically the drive itself, like your C drive or D drive or whatever it happens to be, okay, is the root, the starting point, and then you have this hierarchy of everything that's coming from off of that starting point, okay, from the top of the hierarchy, okay. That's important to keep in mind, because one of the first things we want to look at here is just making sure that we're familiar with how to basically reference files that are being stored in different places, right? That we want to if we want to say, hey, I want to read this file, you got to know where that file is, right? You need to know how to actually be able to say, hey, this is the file I want to reference, okay? We do that with this concept of paths, right? The path is the location of the file, okay? The location of the file. All right, so here, you know, everybody's familiar with this, right? Where you have a situation where you might have a file, you could have multiple files with the same name, as long as they're not in the same folder, right? As long as they're not in the same directory, you could have a file with the same name. So here in this example, we have 4 files with the same name, spam.txt, okay? 4 files with the same name, spam.txt, okay? And they are, they're all in different locations, right? And what we want to keep in mind here is that there's 2 different ways in which we can reference a particular file, okay? One is, let's look on the right-hand side first. Let's refer to the absolute path, okay? This is the location where that file exists, right? And we're giving the entire path location, the exact sequence or the exact place in the hierarchy where it is, okay? So we're saying, hey, it's in this folder or these, if it's in the case of like the bacon/fizz folder, for example, it's going to be in c/bacon/fizz/spam.txt, okay? So we're expressing exactly where down the hierarchy it is, that it's under this folder, then under that folder, it's in this other folder that's within it, and we're going all the way down that path, right? You're already familiar with that, right? You've seen that kind of stuff in the past, just sending files and attachments and things like that. Okay, so absolute paths are longer, right? We're being very explicit. We're saying, hey, this is the exact location where it is, okay? However, that is not the only way in which we can reference a file, okay? The other way that we can reference a file is we can use something called a relative path, right? And a relative path has to do with referring to the current working directory, okay? And the current working directory is, where are you currently? What's the directory that you are currently in, okay? Now, I could do some of this even from the command line here. I could pull it up and say, hey, okay, here I've got a command line. It's a little Linux or Unix window, okay? And I could say, if I do this, pwd, that gives me my exact location, the exact path of my current working directory, or present working directory is what that stands for pwd, okay? Okay, so, however, if I wanted to, I could reference things, okay, I could reference things that are based on this present working directory. Okay. So if I do ls here in Linux, this gives me shows me everything that's currently in my present working directory. Okay, it's everything that's in this D drive Unix/files directory. That gives me everything that's currently there. Okay, if I wanted to reference a file, okay, if I wanted to reference a file, I could do that, for instance, by saying /, okay, like if I wanted to actually display it, more displays to the screen, okay, I could say more and say // says this current working directory's location, show me what's in that that file. Inside that file, we just actually have two numbers that we're going to use later on. Okay. If I wanted to go back one directory, notice pwd, right, my present working directory, right, we're in this Unix/files directory. If I say cd ... okay, and then pwd again, I've gone back one directory. Okay, so one thing I want to point out here is using two dots says go back one, go up to the parent directory, right? The visualization of that here is if we were in this current working directory bacon, if I said cd ... or I use ... okay, I go back up one level in the hierarchy. Okay, so we see the relative path here, this ... right? ... says, hey, go back one level. Go back one level. Okay. A single dot says, hey, give me my current location, the current working directory. Okay. So understanding the single and the double dots are critical in terms of understanding relative paths. You're saying the current directory that I'm currently in, or I want to go back one directory. Okay, so like for instance, if I want to go into, in this case, like the fizz directory, right? I want to reference the spam file inside the fizz directory. I'm going to refer to / my present working directory, which is bacon, right? Then under fizz, then under spam. Okay, so it's / fizz / spam.txt. Okay. All right. You could see that here. If I could show that in this example, right? If I want to go back into the files directory, okay, I could either do cd files, that will actually work. Okay, I could also say cd ... my present working directory / files. Okay, a single dot gives you that present working directory. That's oftentimes necessary. Okay, because you want to say, hey, I'm referring, that single dot is making it really clear that you're referring to where I currently am, the current working directory that I'm operating in. Okay. We can see these examples in this visualization here, right? And now, one of the reasons you might be wondering, why do we care about relative paths? Right? Oftentimes, the danger with absolute paths that we see on the right is that if I go and take something I've built, right, and I use all absolute paths, and then I move it to somewhere else, such as giving it to another person to run, okay? If I have absolute paths in my code, right, and I give something to you to run, it forces you to have everything in the exact same place, or having to change the code and change those paths, okay? By building things with relative paths, usually much, much better, because now I can give you, like, say, an entire folder, and you can extract that folder, right, everything in that folder, as long as everything's laid out inside that folder correctly, you can run it without having to change any of the code or change anything, okay? So relative paths are much better for that kind of portability issue of going between different machines and different people, okay? It's a good thing to practice. All right, I'm going to keep this video really, really short and just stop it there, because the next thing I want to do is see how we are going to apply this concept, or these concepts, in the context of C programming, where we are referencing reading files and writing to files. Okay, please watch it multiple times, and I encourage you, practice, right? Practice this idea of being able to reference different files using relative and absolute paths. Okay, all right, thanks for watching, and I will talk to you soon.